All right, this video is about correlation. Correlation is the relationship between two variables. So we can generally see a correlation using a scatter plot. And when I say a correlation between two variables, it's if we have, for example, number of days of sunshine compared to how large the vegetables grew. Those are two different variables, how large a vegetable grew and number of days of sunshine. Those are two different variables, so we can see how they're related to one another. There is an association between them. So if we have a large amount of data points, we can put them on a scatter plot. So a positive correlation means that the scores on one variable goes up and then the other variable scores go up. A negative correlation is when one of those variable scores goes up, the other one goes down. This is creating a negative linear relationship. A zero correlation is no relationship. So there may be other relationships like curved or a scatter plot that isn't quite linear, or that isn't linear, and it's definitely, there's still a trend though, but it's not linear. There are other correlation ways variables can be correlated and then other ways to calculate those as well. But in this video, we're just going to take a look at our linear correlations. So for example, if we had a scatter plot, oops, I can draw one, that looks something like this. We use a line of best fit and assume that that looks like that. So that's a positive linear relationship. When this variable on the horizontal axis goes up, the one on the vertical axis goes up as well. Conversely, if we had a set of data as a scatter plot that looked like that, and our line of best fit was going down, so as the horizontal axis, as that variable was increasing, the vertical axis was decreasing. Now we have a negative correlation. And then a zero correlation is when these dots are all over the place and there is no trend to them. There are examples in the book that are more nicely drawn than me on my computer. And then an example of one just to be aware of is like if we had a curve, like it looked like a parabola or something. That's not no relation, but it's definitely not linear. So there are other ways to calculate those. But just be aware that you might see those. It just means it's not linear. Now, when we're calculating our correlation here, we actually use lowercase r to denote it. So what we have, lowercase r will always be in between -1 and 1. It's not going to be anything larger or smaller than that. So if a correlation is closer to 1, then it's a positive relationship. We have that positive linear line. If the correlation is closer to -1, then it's a negative relationship. If the correlation is 0, then there is no relationship. So if the scatter plot is not linear or there is no relationship, then we can't use r to calculate it. So for example, if we had 0.73, that's a positive correlation. If we had negative 0.12, this is technically negative, but it's getting kind of close to no relation because it's pretty close to 0. Negative or slash no relation, getting close. If we had one dead on 0, there's no question about it, there is no relationship. If we had a -1, that is a perfectly negative relationship. If we had a positive one, it's a perfectly positive relationship. So we do want to be very careful though. A high correlation, so if we had a -1 or a 1, that these were perfectly correlated, that does not mean causation. Correlation does not mean causation. So we want to be careful of that. In that first initial example of how large vegetables grew with the number of days of sunshine, if we find that there is a high correlation between that is more days of sunshine, the bigger the vegetables grew, that does not mean causation. There might be other factors, soil, location, rain, water, a lot of other things that might have mixed into this. So it's not that correlation does not mean causation. It's very important to keep that in mind. And then the last thing in this video we'll touch on is the coefficient of determination. Now the coefficient of determination is the proportion of variance that two variables have in common. So that's taking a look at the variance side of things. And how we calculate the coefficient of determination is just r squared. So we take our correlation coefficient, r, and we just square it to get the coefficient of determination. Thanks.